they've given us again 3 planes, and we got to find the intersection of these 3 planes. First thing we're going to do is eliminate that they're coincident planes, that any of them are coincident planes. So I quickly take a look. Is 2 a scalar multiple of 1? Definitely not. Y times 5 gives me negative 5. Doesn't happen here. So that's not a scalar multiple. Over here, I'd have to multiply by 2. 2 times 2 doesn't give me 3. Not a scalar multiple. And finally, the last one, 3x, 3x. I only have to multiply by 1. No, it doesn't work. So none of these are scalar multiples of the other. So that instantly takes out all of them being coincident planes or 2 of them being coincident planes. So we're only left with 2 other options now, assuming that these are consistent systems. In other words, that they meet at the same point. So we're going to go through with our consistent systems. Same thing we've been doing with elimination. We're going to eliminate our x. Okay? And what we're going to do is we're going to find 2 new equations. We'll call them 4 and 5. By equating equation 1 with 2 and equation 1 with 3. So in order to get rid of the x in equation 2, I'm going to multiply equation 1 by 3, and I'm going to multiply equation 2 by 2. Okay? The reason I do that, it gives me 6x, and we'll make one of them negative. We'll make this one negative. 6x minus 3y plus 3z equals 3. That's our equation 1. Equation 2, when we multiply by negative 2, gives us negative 6x plus 10y. What was it, negative 2? Minus 8z is equal to negative 6. So that's one of them. Okay. Before I finish that, I got to do the same idea with equations 1 and 3. Okay. And it turns out they're using the same numbers. We're again going to multiply this one by 3 and this one by 2. Okay. Equation 1 by 3 we already know is 6x minus 3y plus 3z equals 3. And our equation 3 in this case will give us, and sorry, I'm going to make it negative again, negative 6x minus 4y plus 2z is equal to 0. Okay, from there, we're going to find our 2 new equations. When we add these out, we're going to get 0x plus 7y plus 5z is equal to negative 3. 0x negative 7y plus 5z is equal to 3. Oh. What are you looking at? Okay, so this now gives us 2 new equations. We'll call the blue one equation 4 and the red one equation 5, and we'll zoom back in a second here. Okay. So really, the way we can write those 2 equations, 7y plus 5z is equal to negative 3, and negative 7y plus 5y is equal to 3. So we have these 2 new equations. We're going to do the exact same thing to try and eliminate our, that's supposed to be a z, not a y, to eliminate our y variable. Okay? Well, because our values or our coefficients of y are the same, we're going to add the 2 together. Okay? So I'm just going to bring down equation 5 over here. We get negative 7y plus 5z is equal to negative 3. Okay. And that's 3. Okay, this will work fine. Now, what you guys have to notice here, so I can add these 2 together. When I do that, I'll get 0y plus 10z is equal to 0. 10z equals 0. Is there a multiple or a number for z that will, multiplied by 10, will give me 0 here? It's supposed to turn out the other way.
Oh, for equation 4 is supposed to be -5.
Ah, this is supposed to be a negative, yes. Something was supposed to be off there. Sorry. I really got to work on this. So that's there. Good, good, good. This should become a 0. That's what I'm, there you go. Okay, this is what I was looking for. So, how many solutions do we have here? Infinite. But, remember, these weren't coincident. If we look back up at the top, we know they're not scalar multiples of each other. These are infinite. What this is saying is these aren't going to meet at one point. There's going to be many points. And for a consistent system to meet at many points, okay, does anyone remember what that will be if they're not coincident? At not one corner, but one line. So this is going to meet at one line. So this part here was good because it told us that we're not meeting at a point, but it's kind of irrelevant now. What we're going to do is, again, like we've been doing in the past, we're going to set our parameters. We're going to meet at a line. Now, equation 4 and 5 are important here because we can just work from them for the rest of the stuff. So our equation 4 here, we're going to specifically focus on it. We could use 4 or 5. It doesn't really matter. And we're going to set a parameter in it and then work backwards like we always do when trying to find a line. So, like usual, I'm just going to set z equal to, let's call it t this time. Okay. When I do that and plug it in for equation 4, 7y minus 5t equals -3. We're going to solve for y. 7y is equal to -3 plus 5t. Y equals -3/7 plus 5/3t. So that's one of the parameters. We now have two of them. We have our first parameter, z equals t. Our second parameter, y equals -3/7 plus 5/3. And finally, how do we find our third parameter? What do we do with these two numbers? We plug them into where? The first equation. Good. Our first equation, or second or third, it's just because it was the first set of equation, equals 1. Is that right? 2x minus y. Yeah, okay. We're going to plug these parameters in to solve for x now. So 2x subtract -3/7 plus 5/3t plus t equals 1. This becomes 2x plus 3/7 minus 5/3t. I'm going to put this to plus 5/5t equals 1. When we do that, our t's end up being, oh, why did I put it over 5? Sorry, over 3. 3/3. This becomes -2/3t is equal to 1. We bring the 3/7 over, so we're subtracting by 3/7. So this could be 7/7. And we still have our 2x. So we collected our like terms. I kind of did it quickly there. I bring the t to the other side. We get 2x is equal to, we'll get 4/7 minus 2/3t. And then if we divide by 2, we get x is equal to 4/14 minus 2/6t. Okay? All right, so from here, when I divide it by 7, the numbers on the bottom should read 7 and 7, not 3 and 7. So this is a 7, and this should be a 7. So now that we've done that, we plug it into equation 1. Equation 1 read 2x minus y plus z equals 1. You take the parameters, 2x minus -3/7 plus 5/7t plus t equals 1. We're going to change these to fraction form when I bring the negative in. It'll still say 2x, but we're going to say plus 3 over 7 plus 5 over 7t. I'm going to change the 7 to, sorry, that should be minus 5 over 7t. This will become 7 over 7t, just so we can work with it. And I'm going to turn this number to 7 over 7 also, so we can actually do something with these fractions. When we equate the t's, we'll get 2 over 7. And when I bring the 3 over 7 fraction to the other side, it becomes negative. So 7 over 7, subtract 3 over 7. And we still have 2x. We're trying to find x, so x is equal to negative 2 over 7t plus 4 over 7. I can then divide these by 2, and when we do that, it's actually just going to read 1 over 7t plus 2 over 7. Okay? I simplified them. It would have really read negative 2 over 14, which is the same as 1 over 7. 4 over 14 is the same as 2 over 7. So that is our third parameter, which means way back in the beginning we were trying to figure out where do these three planes cross each other. It is at that line there that all three of these planes cross each other. Okay? They cross at a line, not a point.